to. And we'll start up the browser. That's the mic. Oh yeah. The mic is not working because I think it's out of battery. Yeah, it's out of battery and there's no spare battery that I can see. Fine. Yep, so there's no mic today. I just have to use my own voice. But the recorder is on. I just need to double check and make sure that is the case. Yep, so it is recording. And we'll go ahead and get started. Let's see, do I need this? Yes. All right. Okay, so the class has started. Do you guys have any questions for me? No? Okay. All right.
There's a question over here.
Yeah, go ahead.
Did you go through the two truth tables for conjunctions and disjunctions?
Okay.
So I don't really understand disjunctions.
Disjunction is OR, just OR. That's basically what it is.
So if both x and y are true.
It is true, a disjunction is true if at least one side is true. They can both be true, or just the left-hand side. Okay, excuse me, I kind of need, okay. So you can have true or false is true, false or true is true, true or true is true. The only way to get an or disjunction to become false is when you have false or false. Okay? Is that okay?
Yeah.
Okay. All right. So we are done with topic 1. I really should update all this stuff here. We are on to loops. Okay. Last time we talked about pre-checking loop, which means you check before you perform any action, which means you can also avoid the first action. You can avoid the action altogether, because if the condition coming in is already false, then you avoid even one single action. So what we'll do today, or what I'm going to do today, is to review a pre-checking loop first, and then we'll talk about the post-checking loop. Okay. And we'll start with the drawing of a pre-checking loop. It is in the notes itself, okay? So you don't really have to copy this because everything is in the notes, and the link does work now. Okay, so with a loop, you always end up with a way to go back to an earlier point. So when you draw that, you might as well just leave that as an option, so you can backfill a path to go back to that point. This is not working that well. This is really wasteful. If you think about it, every time I throw away one of these things, where is it going?
Landfill.
The landfill. Okay. Yep.
You forgot to turn on voice recorder.
The voice recorder is on. I already checked.
Okay.
Yeah, it's just that I don't have the mic is not working, so I have to use my own voice. So, but this is really kind of wasteful because there's a lot of material, a lot of plastic, and the only reason it is not working anymore is because it runs out of ink or what pigment or whatever you want to call that. So if they have a way to recharge this, it will be so much better. You just kind of go back to a recharge station, plug it in, okay, and let it just recharge. Then you can reuse it, because the felt tip for the most part is still okay. I think it's still good for maybe another 2 refill of the ink. Then you can just change out the felt material, because the plastic container is much more durable than the rest. Okay, so I think okay. So for those of you who are enterprising, this is an idea. Okay, this is an idea. Run a shop where you can turn these things into reusable form. Okay, just take a default or a stock one, turn it into something that is reusable, and have a recharge station that can re-ink these things, refill it. Okay, I think it's a business idea that can potentially really work, especially if you can convince community colleges to subscribe to that. Think of the number of whiteboard markers that we throw every single day in a single community college. Okay, so a few, probably maybe a quarter or 50 cents, now is down the drain. Okay, could have been your profit, could have been money in your pocket. Okay, ideas. Getting back to loops. So I'm going to finish this picture here. Okay, so the first thing you do is, see, this one is also not good. I mean, this is really wasteful because it's not like it's not working entirely, but the contrast is not optimal anymore. Okay, so a quick recharge, which will cost in terms of material maybe 5 cents, 10 cents at the most, will bring it back to life. So anyway, so we have a branch, and because we do have a condition to evaluate. Remember, this is called the precondition because we check the condition first. The condition is always a question. It is a question that has two possible answers, true or false. Okay? And the convention that I use in this class is I always put the true branch on the left-hand side, but that's just me. Okay, this is not any actual programming language convention. There's an action associated with the loop, okay, something you can do, but when you're done doing this, you go back to the earlier point. That makes it a loop. And remember, this is a one-way thing. You cannot go the other way. You're coming in here. You can go this way, or you can go the other way. What about the false branch? Because every time you have a branch, you have two ways to proceed. One way to proceed is to do something and then go back to an earlier point so you can read the instruction again, read the question again, and then determine which way you want to go. But once this condition is false, then you follow this branch and you get out of the loop. This is a pre-checking loop. Are we doing okay so far? The pre-checking loop is the one that makes sense in most cases, but not all. Okay? The only reason why this may not make sense is the condition depends on the action itself that has a potential of having to do it again. Okay? There's one example in my own notes that explains why this may not make sense sometimes. Now, last time we used the exercise or jump rope example. You guys remember that? We say, while not tired, okay? I think these are the steps. So we say, but flip the rope and jump, okay? Something like that. And then after that, you follow this path, you go back again and say, am I tired? Am I not tired? If you're still not tired, go for another skip, go back. So you keep doing this until you're tired, okay? Then the condition of not tired becomes false. Then you follow the branch labeled false, and then you proceed to whatever is next. Take a shower, whatever, okay? Is that okay? So the point is, if you are coming back from the gym to begin with, you are already tired, then you can avoid jumping rope altogether because the condition is false to begin with. You follow the false branch immediately without doing a single action at all. Yep.
So is the statement while both a question and an instruction?
The word while is what we call a keyword. It is here to identify what is the rest of this construct. If is another one, and then later on we'll have repeat, which is another one, okay? But this is basically just a word to remind you, oh, this is a pre-checking loop. It's the same thing as long as. It's nothing more than really just a keyword to signify and say, oh, this is the beginning of a pre-checking loop.
So you don't need so the fact that it's a pre-checking loop means that it's also a question because it has
means there is a question somewhere, okay? So the question in terms of syntax of our pseudocode, which closely resembles C and Visual Basic, is the condition is right next to it because that's how we read the instruction. So while, in this case, not tired is the condition. And then in this class, I use do, but if you don't use a do in your pseudocode, it's not the end of the world. That is the reason why we have pseudocode. It's not very picky. So in this case, we have jump and turn rope, and then we have and while. That's the syntax. That's the text version of this. Okay, this condition or this question is the condition here.
Okay.
And then the action that you perform for each iteration is inside here. The rest is nothing more than just markers to say this is the beginning of the entire loop, which is basically signifying the beginning point here. This is signifying the end of the loop, which is basically this point here.
So could you write that where a false outcome causes the loop?
Not in this class,
No? Okay.
because in certain programming languages like Visual Basic, you can specify until da 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 do something, well, which is the flip side of this. But since most of you are going on to cisp300, which is C and C++ programming, this is the more usual way to specify a loop. The other one is just looking at the condition, but on the flip side. Okay, good question. Any other questions about this? Yep.
So like all these conditions, I know this is hypothetical, we're not talking about a real program, but all these conditions would have to be previously defined, right, in the program, like not tired. Like how does the program define
Correct.
what not tired is?
Yes, there has
also,
to be
would that rely on the go-to calls that you were talking about earlier, or was that already in the programming language so that it knows what all those commands are?
I'm assuming that not tired is something that is already known to the computer, or the computer knows how to evaluate what is tired. Okay. Later on today, we're going to use examples where it's really concrete, using numbers, okay, and assignment statements, and all the other stuff that we have talked about so far. So just kind of hang in there. I will give you guys solid, concrete examples. All right, so this is a pre-checking loop. Post-checking loop, as you probably already expect, means you do something and then you check, okay, should I do it again, right? So why would we want to have post-checking loop if this handles the majority of all the cases?
Sometimes you want to, going into the loop that you already have to perform the action at least once.
Right, but the idea of having to perform the action at least once, most of the time it has to do with the condition, the very condition that you use to determine whether to do it again is relying on the outcome of the action. Okay, the action is what sets the condition. So you have to do the action first. You don't have a choice. Okay, so I'll give you an example. It is actually in my notes here. Well, might as well just go there, right? Okay, so I go there, go to repeat. Well, maybe not that one. There we go. Okay. So this is a very typical example of why you want to use a post-checking loop. Because if your logic is prompting an end user to enter a zip code, and you won't let the end user go until the zip code is valid, that is how you express it. So that's the text version. Let me draw the picture. The picture is probably in a note somewhere as well, but it's okay. I'm going to draw it here. Okay, so we'll leave a point to go back to, right? And then we specify the action here. In this case, the action is ask for zip code. Okay, that's the action. So right after this action, I have a zip code that the user entered. Makes sense, right? Then I can ask that question. I can now have a branch here and ask, is the zip code valid? Because from 00000 to 99999, some of those numbers are not used as zip codes. So you need to have a database to help you check whether the zip code is valid or not. So based on this answer, once again we have one branch labeled T, true, the other branch labeled F for false. If it is true that the zip code is valid, then we continue execution with whatever is after this. The condition has been satisfied. On the other hand, if the zip code is invalid, well, I guess I opened the notch on this wrong side this time. Okay, there we go. Then we go back like that. So this is a one-way thing. This is one way. This is one way. One way. That is a post-checking loop. It's called a post-checking loop because you perform the check. You check the condition after you perform the action that has the potential of being repeated. Are there any questions? Yep.
But couldn't you do that with the other loop as well?
Sort of. Okay? If you want to emulate the effect of this using a pre-checking loop, what you need to do is to put the action here once, and then you specify the action here again. Because this type of loop, the pre-checking loop, is always asking the question before performing the action. So if you want to force it to perform at least one action first, then you have no choice but to replicate what you have here over here. But yes, it will have the same effect, but it's not good from the organization perspective. Anytime you do a copy and paste in programming, you have to ask the question, do I have to copy and paste? Because copying and pasting is a bad idea in programming. We'll talk about why that is the case when we get to subroutines. So are there any questions related to post-checking loops? So I'm going to write out the text version of this, which is also in the notes, so it's not anything new. So it starts with the word repeat. Okay, so repeat once again is a keyword. It tells the compiler or the person reading this what to expect next. Okay, so in this case, you specify the action, which is ask for zip code, which is the action. Then when you're done with specifying all the actions, then you have the word until, and you specify the condition to get out in this case. Because when people use the word until, we're always saying until something is done. Okay, you're specifying the exit condition, when do you stop the repeating. So in this case, it's until the zip code is validated. Pictorial representation, text representation. Now in C and C++, they use a do while loop instead. In other words, the polarity of this condition is reversed. But in this class, I choose to use repeat until because it is closer to how we do things or how we say things. Because I think we use in repeat until a lot more frequently compared to do while. Okay, the word while is not really that commonly used. When we do want to use the word while, in this case, most of the time we say as long as. Okay, it's just not a common word to use. So are there any questions about repeat until versus while do? Pre-checking versus post-checking. Well, if then, yeah, go ahead.
Oh wait, never mind. That's the tip. Yeah, no, never mind.
Okay. So what we'll do next is we're going to trace some algorithms using loops. Okay. So this is where it will address your question. Because these things is kind of like fuzzy. Okay. But how do you decide, or how does the computer determine whether type is true or not? Okay. It's fuzzy. How do we know whether a zip code is valid or not? Well, I didn't really tell you how to do it, okay? So, but in the next example, we are going to have exactly, all the concrete steps to do stuff that can be traced. So once again, I use a spreadsheet to do this. And let's go ahead and start a new document, new spreadsheet. I always put the pseudocode in sheet 1 and then put the trace in sheet 2. So let's go ahead and specify a particular program. We'll start with something simple, okay? Something that actually is fairly easy to trace and it makes sense. X gets initialized to 0. And then we have while x is less than 5. Well, let's give 3 because otherwise it gets really boring. And then we have x gets x plus 1. And while, and number the lines. Okay, so we have line numbers, the actual code. What I'm doing here is I'm selecting multiple columns and then I'm resizing the columns by double-clicking the border here. So this way, each column only has to be as wide as it needs to be. This one needs to be indented. Unfortunately, in this particular spreadsheet program, there's an indent key, which is down here. I just don't have enough screen space to have it displayed, on its own. Well, when you run LibreOffice on its own, using a larger screen, you won't have this problem. Okay, that button will be displayed. Okay, so this is the pseudocode. and I need to use a new window to look at the trace. So I'm going to say new window, and now we have two windows looking at exactly the same thing, which is not necessary because I don't need to look at the pseudocode from the second window. The second window is going to take a look at sheet 2. If sheet 2 is not here yet, you just click the plus button to add a sheet 2. And we have basically the same thing as last time. Okay, we have line number as one column because I need to indicate, oh, this is the result of executing line blah blah blah. We have only one variable in this case, which is x. Okay, but when we are dealing with conditional statements or loops, we need to have one extra column. That one extra column, okay, insert column left, I will just say it's comments. Okay, so we'll talk about how to use this column as we trace this algorithm. What is the first row of a trace? What is the line number? Pre, okay? Basically, if you want to say anything that you know about the variables prior to the execution of the entire algorithm, this is where you put it, okay? So you use a pre as the line number, but since we don't really need to know anything about x, we can just put a question mark here to basically indicate that x is a variable that starts with an unknown value when we start the algorithm. Yes?
So, can you explain to me again? Pre isn't line 1.
Pre is not line 1 because remember, each row indicates the value of the variables after you execute a line. So I cannot use line 1 here because I'm trying to state what we know about the variables before line 1 executes, right? Because sometimes the precondition is useful, but in most cases it's not.
And then when you put line 1 and you add a value to x, that would be the result of the line 1.
It is the result of executing line 1.
Okay.
But since we have not executed line 1, this is the precondition.
Okay.
That's why for the question mark is we don't know what the value is.
Okay.
All right. So let's move on to line 1. What do you think is the result of executing line 1? X ends up with a value of 0. Very good. Okay, so that's pretty easy. Here comes the kind of new stuff. Okay, this is new to us because we have never dealt with a while loop before. I kind of forgot to talk about this when we talk about conditional statements. So we'll go back and talk about conditional statements too. This is line 2. This is line 2. Line 2 has no business with x because are we updating x on line 2? What are we doing instead with line 2 with x? We are just comparing, right? We're just reading the value of x. We are not changing the value of x. So that's why there's nothing we can do about column C because we are not changing it. On the other hand, we are evaluating a condition. This is where the comments comes in handy because I want you guys to use the same convention when you do your homework, is repeat the condition itself. So when we execute line 2 in the algorithm, we are evaluating the condition x is less than 3. So you just repeat the condition itself. Then you have to tell me, is it true or is it false? Well, what do you think? At this point, it is true because x has a value of 0. 0 is less than 3 is true. That is what you need to say in comments when you are evaluating a condition. Are there any questions about row 4 of the trace? Not line 4 of the algorithm, but row 4 of the trace, which is where we are at this point. Yep.
So in row 4, x is still 0?
That is correct. It is still 0 because we have not updated it. So if you see a blank here, you basically have to keep going up until you actually see a value. That is the current value of the variable. Yes?
Why do you know x is 0?
How do we know it's 0? Because after line 1 executes, it gets a value of 0. Is that okay? Because the effect of storing something into a variable is it will keep that value until it is updated. Yep.
So basically, line 1 is telling you right there that x is less than 0.
No, line 1 this is basically a left arrow symbol.
Oh.
So it's assignment. It's updating.
Oh, okay, so it's telling you right there x is 0. If
Yeah,
that
it's
0
x-
was a 1, then x will be 1.
Yeah, it's basically saying x gets 0.
Okay.
Mm-hmm.
And if that was a 1 or a 2, then
Then you would
the number
reflect
2
that over
would
here.
still be true, right?
Correct. Yes.
Okay.
Yep. I'm just using less than dash to
Yeah.
mean the
Error.
assignment operation.
Okay.
Yep. Okay. Any other questions? If I want to be anal about this, I can just replace this and say insert
Yeah.
special symbol thing. Where is it? Special character, and then go to the proper page. It can be done. It's just a little bit of searching and locating.
Alt code for it.
Sorry.
You should probably just look up the alt code.
Yeah, the alt code is one. Open symbol probably has it right there. Okay, we have all the arrows, so we just need the left one. This one is okay. So I can do that. I mean, it's just more time consuming that I would like to do. Yeah. Same thing with line 3. It's just a left arrow.
Yeah.
Okay. All right. Getting back to the trace, right? Now, since we know the condition is true, what do we do when the condition is true when we have a while loop? Look at this picture here. When the condition is true, which branch do we follow? The true branch. But that takes us out of the loop or into the action of the loop?
Into the action.
Into the action of the loop. So which line is the next one? Which line should I execute after line 2 in this case? Line 3, because it is in the loop itself. And what does line 3 do? Line 3 is an assignment statement. We have x plus 1 on the right-hand side. We have x on the left-hand side. So what is it doing? X becomes 1. Okay? Because once again, when we have an assignment operation, we evaluate the right-hand side using the current value of all the variables. The current value of x is 0. 0 plus 1 is 1. Okay? Then the right-hand side is done. What do we do with the value of 1? We update the left-hand side with that value. What is on the left-hand side? It specifies the variable x. So x is the one that is now updated to a value of 1. So we have to reflect that in the trace and make sure that we update x with a value of 1 over there. That's the end result of executing line 3. Remember, each row indicates after which line what is the result in the variables. So that's what we are doing here. Are we doing okay so far? Okay. Where do we go next after line 3? Look at the picture here. We're done with this action. We follow the path, and then we go back to what do you think is the line number corresponding to that point? Line 2. Yep. Then what about line 4? Line 4 doesn't do anything. So it doesn't even appear in the trace. We'll see why it is not even going to appear in the trace. So we go back to line 2. What do we do on line 2? What is the first thing we do on line 2? There are 2 things to do. Yep.
Check if x is less than 3.
Exactly. We evaluate the condition. Okay? The condition is still the same. X is less than 3. But x is no longer 0. X is now 1. It is still less than. Right. So over here in the comments, you still have to say the same thing. X is less than 3 is true. Okay? And because it is true, where do we go next? 3. Okay. And this time x is updated to 2 because at this point x, the current value of x is 1. Right? Now how do we know it's 1? Because you look up, you keep going up until you see an actual value. That is the value, that's the value of the right-hand side the last time you update x, which is the current value of x. So when you evaluate the right-hand side on line 3, the current value of x is 1. 1 plus 1 is 2. That becomes the value of the right-hand side. Then you use the right-hand side to update the left-hand side. The left-hand side specifies variable x, so variable x is now updated to a value of 2. Are we okay so far with this? Okay. Then we go back to line 2, and what do you think we should do here? We repeat the condition itself, x is less than 3, is true, because 2 is less than 3. And if you think this is really boring, I am glad. Okay, it means you're getting it. Okay, you're getting this. It's like, oh, we're doing the same thing again. Okay, you're reapplying the same concept. So if you think this is boring, good. We go back to line 3. What does line 3 do? It just adds 1 to the current value of x. It is now the current value is 2 prior to the execution of line 3. You add 1 to it, it becomes 3. Then you go back to line 2. This time you have to be careful, because x is less than 3 is now false, because x is 3. 3 is less than 3 is not true. It is false. Where do I go next? We don't go to line 4. How do we mark the end of a trace? Post. We go straight to post. Okay, we don't go to line 4. We go straight to post. Because line 4 is not really doing anything. There's nothing to do, and as a result, we don't trace. Sorry?
It's just like an instruction.
It's just like a marker. It's like a bookmark that indicates, oh, this is the end of the while loop. But there's nothing to do as a result of that. Yep.
So on a post-checking loop, the line of repeat would not show up either.
In a post-checking loop,
Yeah. So repeat while until.
the word repeat, the line of the repeat is never shows, but the word until does, because we do have the condition to evaluate.
Correct.
Yep. So are there any questions about this trace? Let me zoom out a little bit so we can see the entire trace like that. Are there any questions about this trace? No questions? This is all good? Okay. All right. So if this is all good, I'm going to close this document and then we'll start a new one. Okay. So let's start a new one. And this time we'll deal with repeat until. Okay. So all of these cases are not really tricky. I'm not getting to the tricky part just yet. If I want to use the left arrow symbol, I can still do that. I have to go to Tool, go to Autocorrect, and turn on the replacement table, which works for the most part, but there are certain things that I might need to tweak later. Okay, so there we go. So now we have X. This time it automatically converts it into a left arrow, but there are certain things that I don't want it to do, but we'll fix it as we get there. Okay, so this time let's start with a higher value. Let's initialize X to 5. Then we have repeat X gets X minus this time 1. And then we can say until X is less than a particular value. So let's say 3. Okay, there we go. Indent this particular one. I'm sure there is a shortcut key to do this. I just don't know what it is. So once again, you can select multiple columns and then go to the border right between 2 columns until it becomes a double-sided arrow. Double-click it, then it will resize the columns until they are just taking the necessary amount of space. Okay, it's just a little trick, but it's a nifty, useful trick. You go to Window, you click on New Window. It will open up another window on the same document. So this way we can use one for the algorithm and then use the other one for the trace. Click the plus symbol here so you can create a new sheet in the document, and that's how you set up the trace. We still need comments as a column because we do have conditions to evaluate. We have the usual line number, and then we also have one column for the only variable in this case, which is X. The precondition is going to be a question mark for X because we don't need to know anything about X, because the first thing we do in this algorithm is to override it. So even if you assume that we know X is 5 prior to the execution of this program, or I should use 5, but 20, okay? It's useless because the first thing we do is to override it with a value of 5, okay? But we still want to document the fact that we don't know anything about X prior to the algorithm, okay? So line 1 doesn't do much, X just gets a value of 5, okay? Then we go where? Remember what we talked a little bit earlier. There's nothing to do for repeat. We don't trace line 2. Okay, what is the next line that actually does something? Line 3, okay, because this is a post-checking loop. You're coming in from line 1. Line 2 is just a marker to say where the loop is beginning, but we don't do a single thing. So you have to go straight to here, the action inside the loop. That is the next line that we trace. On line 3, instead of adding 1, we are subtracting 1, so it goes from 5 to 4. Then we go to line 4. Line 4, even though it seems like there's just a word to mark the end of a loop, it does a little more than that, because there is a condition here that we have to evaluate. Every time you have a condition to evaluate, you cannot just skip over it. You have to document what is the value of the condition. So now you have to go to here and say x is less than 3 is, it is false, okay? And in a post-checking loop like this, what do we do when the condition is false? You follow the false branch, and the false branch will bring you back to the action, okay? So what is the next line that we have to go to? We go back to line 3, okay? We go back to line 3, and we subtract 1 from x again. It goes from 4 to 3. Then we go to line 4 again. X is less than 3 is false, okay, because they're the same. Then we go back to line 3 again. This time x goes from 3 to 2. We go back to line 4. X is less than 3 is finally true. And what do we do when it is true? You go to the next statement. What if there's no next statement? Post. We are done with the trace. Very good. You guys already are getting the standard or the convention that I'd like to use in this class. Right. Are there any questions about this particular trace with a post-checking loop? No questions? This is all good?
So this one was the what? The repeat, and that one was the what? So we have to kind of remember those two when we're doing this.
Yes, you have to understand it. Okay, whether you want to memorize it is up to you. Remember, the test of this class is open book, open notes. So ideally speaking, you don't have to memorize a single thing, but you do have to understand what it is in order to do, to answer the questions. Okay? I do not test memorizations in this class. It's open book, open notes. For stuff that you think, okay, I may not be able to remember this in an exam, write it down on a piece of paper. So when we have the first, second, or the final exam, bring that piece of paper with you. You can bring whatever amount of stuff you want to bring with you, as long as it is either handwritten or printed prior to the test. Yep.
We kind of skip over line 2 because it's just telling us what to do with line 3 and 4.
Yeah, line 2 is the only purpose of line 2 is to indicate the following thing is a code check. But it doesn't really do anything while we execute the code, and that's why it doesn't appear in the trace. Good question. All right, so with this done, we're going to go back in time a little bit because I forgot to give you an example with conditional statements. Okay, the conditional statement, the if, else thing, okay? So we'll go back and do that. So if there are no questions here, I'm going to close this document. Okay. If you did not copy everything that was on the projector, don't worry, the video should have it, okay? So that's the way to take classes from me. What about the next class, cisp300? Well, it depends. Okay, if I am teaching cisp300 and you're taking that section, same thing, okay? I do screen recording whenever it is possible. What if it is somebody else? What if it's Damon Antos? What if it is Iraj Subsaveri? They do not do screen recording. Then you have to jot down your notes and use your other conventional way of taking notes. Okay. All right, so let's go ahead and take a look at conditional statements. So we open up a new spreadsheet, write the code first, and then we'll do the trace. Now this time it's going to be a little bit interesting. So let's say we just we're obsessed with finding the maximum of 2 variables. That's what we're going to do here. So we say, if x is greater than y, then the following. Z gets x in this case, else z gets y, and if. I'm hoping this looks vaguely familiar at this point. If you think this is not just vaguely familiar, this is boring because we have been doing the same thing over and over again, once again, I'm glad because you remember what we talked about in the previous classes. Okay, so we'll redo the resizing and do the indentation. The indentation is not really just for show, it actually has an importance, okay? But right now I'm not going to talk about that because it won't be significant until we get to nested statements. Okay. Now we deal with the trace. Now, this one is a little bit interesting when it comes to tracing it. Start a new sheet, nothing really interesting about that one. Open a new window to look at the trace, nothing really interesting about that one. We need a comments column because when we evaluate the condition of a conditional statement, same thing. We have to indicate is it true or is it false. We have one column for line number, one column for x, one column for y, one column for z. Okay. So far nothing really too strange. Okay, so let's take a look at the variables. We'll take a look at z first. I will say that z can be uninitialized, can be anything. Because remember, the purpose of this algorithm is to store the maximum in z. So I don't need z to have any particular value before this algorithm, okay? Because we are going to overwrite it. X and y are different. So this time, it doesn't make sense for x or y to be question mark because I cannot compare an unknown value to another unknown value. There's no way I can tell what the result is going to be. So I have to give it specific values in this case. So we'll just say that what if x is 3 and y is 1, okay? That's my precondition. You do not ask why x starts with 3 and y starts with 1 because it is given to the algorithm for this particular instance. Okay, and that's why it's called a precondition. Okay, this is what we know about the variables before we start it. Well, given that is the precondition, what do we do on line 1? Are we going to do anything with these cells on line 1? Well, line 1, the only thing we do on line 1 is compare and then decide where to go next. Those are the two things that we need to do on line 1. The first thing first, we have to find out what is the value of x is greater than y. So you say x is greater than y is it true or false? That x is greater than y. Okay, it's true because x has 3, y has 1, 3 is greater than 1 is true. Okay, fine. Then where do we go? This is a conditional statement. Yep. Line 2, exactly. We go to line 2. Now line 2 is an assignment statement. Every time you see an assignment statement, one of these cells get updated. Okay, one of them is going to get updated. In this case, we know that Z is the one on the left-hand side, so column E is the one that is going to be updated. Okay, good. Now we go to the right cell. We know this one is going to have a new value. What?
X.
X, okay, and the current value of X is 3, so Z gets updated to 3, okay? So now we have 3 here. Trick question, where do we go next? Host, very good, good job, okay, because this is a conditional statement. Once you are done with one of the branches, okay, you choose the branches based on the condition, but when you're done with the branch that you have chosen, you get out of the entire thing. Are there any statements after this? Nothing, okay? So that's why it is host, because we are done with tracing this algorithm. Here we go. Yep.
Question. So right now I know you chose the 3 and 1, but when we have a condition or when we have this problem, we would actually have whatever value that is provided to us or given to us.
Correct. Well, when you evaluate the condition, hopefully at that time the variable has something. If the variable still has a question mark at that time, then I have made a mistake in the question itself because you cannot evaluate the actual outcome of the comparison if you don't know what you're comparing. So it's all based on what the algorithm does. Okay. So if I specify the algorithm or the precondition incorrectly, you might end up with, oh, I'm comparing, but I'm comparing at a known value. So what do I do? Well, just write down, this code is not going to work because you don't know what you're comparing. But that only applies when you're tracing. We'll talk about the other stuff later. But for tracing, you need to have a specific value to compare. All right. But for this one, because I do not have any initialization here for x or y, I can now create another scenario to trace. I can now use sheet 3 to create another scenario. Now, being lazy as I am, I'm just going to copy and paste a few things like that, okay? And then specify in the precondition of this particular trace, I'm going to have x being 2 and y being, 30 in this case, and z starts with an unknown value. But just to exercise the other branch. Okay, so this is a slightly different test case, but remember, you don't ask why the precondition is like the precondition because it is given to you. Okay, your job is to execute the algorithm based on what is given to you. So once again, we start with line 1. Okay, so we start with line 1. Line 1 is still doing the same thing. It's doing the comparison. X is greater than y is it's false because x has a value of 2, y has a value of 30. 2 is greater than 30 is false. Then where do we go? We go straight to line 4, not line 3. Because the purpose of line 3 is syntactically mark the beginning of the else branch. It doesn't do a single thing. It's only there to mark the beginning. It's kind of like, when you speak, you don't pronounce the punctuations. Okay, the comma, exclamation point, question mark, semicolons. We don't say those ones, right? We don't say those things because they're only visual aids when you're reading. But when you're listening or when you're talking, you don't use those things. Kind of the same thing. Okay. So we go straight to line. We don't use line 3. We go straight to line 4. And what does line 4 do? It's an assignment statement, which means something is getting updated. The left-hand side specifies z, so we know z is the one that is getting updated. It's updated to the value of whatever is on the right-hand side. The right-hand side is just y. Y has a value of 30. So z is updated to 30. And we're done. Because that's the only thing that I specify in the else branch. When you're done with that branch, you get out of the entire conditional statement. Are we okay so far with this? Okay. So this is tracing, and this is what we're going to do for the entire semester. The good news is we have talked about every control structure that I think is useful in programming. A control structure is like a conditional statement, a pre-checking loop or post-checking loop. It's called a control structure because it helps guide where do I go next. Okay, those are the control structures. We're done with control structures. So what else are we going to do for the rest of this entire semester? Now we have lots of stuff to talk about. Yep, go ahead.
We're going to be combining them, right?
How to combine them, exactly. So at this point, I have shown you about this particular Lego piece. I have shown you that particular Lego piece, and also that particular Lego piece. We have basically 4 different types of pieces now. Assignment statement is one. Conditional statement is the next one. Pre-checking loop and then post-checking loop. Okay, and there's one implicit one which is just a sequence. Okay, you specify these things in sequence and then you have to execute in sequence. But we haven't really talked about how to combine these things. Okay, and that is where things can be interesting. Okay, so let's go ahead and go back to the notes to where we are at this point. Okay. So we go back to Moodle, and then we go to nested statements. Okay. Okay. I forgot to fix this one. How many people figure out how to fix this yourself? I suppose it may not be easy to do it. You won't do it. Because it doesn't show you the URL, so I apologize for not having this fixed. Sorry?
I just got into loops, I couldn't get them.
Okay. All right, so I have to fix all of the other ones too. Let's see, settings. And it's not some profs, it is Moodle, not plus3os.edu. Save and display, that should do it. Yep, there we go. Okay. These are the 5 things. I'm just going to click on each one. I'm using this as a cue of what to talk about, but I'm not going to read from it. Okay, you can read from it when you have time, or some of you don't even need it once I explain it in class. So let's not talk about programming. Let's talk about something else that is also kind of nested and has a structure to it. Okay. The first thing I usually do is maps.google.com. Unfortunately, it is smart enough to kind of go to the places that I usually go to. So I'm going to have to zoom all the way out to the world. There we go. Okay. So now the question is, what am I looking at? It's a map of Earth. Okay, it's a map of the entire world, on Earth. Okay. Is ARC on this map? Yeah. Can someone point to where ARC is? Probably one of those stars, right? one of those bunch of stars down here. Okay, great. But you can't really pinpoint. Why not? Because WildTech, you change the resolution of the screen to 1024 by 768, and Sacramento is by scale so small that it won't appear, as more than a fraction of a pixel, and we cannot display a fraction of a pixel. Fine, okay, let's say that's a physical device limitation. Now I give you a magical projector. A magical projector that has infinite resolution. It can make things as small as it needs to. Okay? Then it should be here, right? We should be able to see ARC with a projector that has an infinite resolution. And let's say I give you a magical loop. So you can actually walk up to the projection screen and actually inspect this part here and actually locate Sacramento. Well, you may be able to do it. What if I present this map to someone who has no knowledge whatsoever of geography in Northern America? So I picked up someone, from, I don't know, this map here, New Guinea. Okay. So I pick up someone from New Guinea who has no knowledge whatsoever of, anywhere in the United States, and say, well, ARC is somewhere on this map. Find it. And remember, it has infinite resolution. In other words, if you zoom in well enough, you can actually see individual trees in New Guinea. So the information is there, but how do you find it? Signs. Okay, but we're talking about someone who has no idea of even where's the United States, or where's California in the United States, where's Sacramento in California, and so on. It's impossible. Okay? Well, it's not impossible, but it is improbable that someone can solve that problem anytime soon. Many of you are young enough that you do not need to read actual physical paper-based maps. Okay? But for those of us old enough, when we plan a trip, what do? We go to AAA, and then you pick up a big stack of maps, like physical, actual maps, right? If you try to visit a relative in another town that you're not familiar with, you pick up a map of that town. Then where do you find how do you find an address? The map is like this big, right? The print is like this small, and you want to find a particular place. Now, fortunately, they do have a key based on street name. They will give you like a list of grids and say, okay, this street spans these particular grids. Helps a little bit. But most of the time, you still have to look through each individual grid. And if you're trying to look up something, let's say in New York City, good luck. Or San Francisco, good luck. Because there will be so many things within one single grid square that you will still have to manually search through and go through all the words. Okay? That's because we don't have structure. Okay? Structure helps to locate stuff. Another analogy of what it is like without structure is, okay, so can someone tell me what is the quote-unquote de facto standard size of a hard drive, internal hard drive for desktop computers? How big have they gone so far? 2 terabytes, 3 terabytes or so? If you buy a new computer from, let's say, Costco, okay, what is the usual size of the internal hard drive? 1 terabyte? Okay, 1 terabyte, which is a lot, right? Now I'll give you a restriction. You cannot have folders. Okay, so when I give you a drive 1 terabyte, you go like, wow, that's cool. I can store a lot of pictures, a lot of music, even movies onto that 1 terabyte hard drive. But then the second restriction is you don't have folders. Everything goes into the root folder. C:\/ is all that you have. You still have the capacity of 1 terabyte. What is the problem? How do you find something, right?
You can open up the command line and start looking through everything. Start at the top.
Compare, yeah.
Named it right.
Yeah, exactly. Naming convention. Okay, but when you download pictures from the digital camera, what do you get? img_2695.jpg, right? JPJ, okay. JPG, okay. And then you end up with what? Thousands and thousands and thousands of files with names like that. Now you normally would be able to organize at least by time. Okay, that's what most people do, is you just kind of create a folder of a particular date and say, okay, these are the files that I downloaded of that day. So you can at least use time to kind of get you close to the picture that you want. Okay? Some people are more organized and they can organize by trip, they can organize by people, event, and stuff like that. But without folders, it gets a little difficult. Okay? Same thing with programming. Without the ability to structure a program, you may be able to specify all the instructions to get something done, but in order to find out where is that line that is responsible to do that thing, good luck, you cannot find it. How many people have taken English writing, I think 300, that's the college level writing class, okay? So what is a typical, what is the final paper that you have to turn in? What is the length of the final paper that you have to turn in? Sorry?
10-page research paper.
10 pages or so? So how many words are we talking about? Just guesstimate, I don't need the exact number.
It's like 2,000 words.
2,000 words, okay. And it's usually a paper on something that you have to argue, that you have to describe, that you have to, it's more than just writing, right? It's not just typing senseless words on the keyboard. You actually have to convey an argument, a concept or something like that. Do you just sit down and start on the first page, the first word, and just keep typing until you're done with the whole paper? Never have to go back again or do anything like that. No. So how do you do it? How do you write the final paper for English Writing 300?
You research it, make an outline from the intro and each paragraph's points, an outro, where you're gonna put all of your citations.
Yep, you organize it. Okay, I like the word outline, okay? Because that is structure. Because now you can say, oh, certain things go here, certain things go here, certain things go here. Okay? That's the same thing with programming. Okay? So when we talk about structure in programming or structured programming, we are talking about pretty much the same stuff. Okay? It's just a way to help you organize your code in this case instead of your paper or something like that. It is just code. Okay? So now we go back to the notes. Obviously my tabs are not organized, so that's why I am having such a hard time of finding my stuff. Wrong thing. Oh, okay, there we go. Maybe. Oh, okay, I can always navigate back to it. But once again, this is structure because there are many, many classes hosted on this Moodle server. I know I'm dealing with CISP. That helps to limit to a certain number of classes. Because otherwise, I'll be searching through psychology classes, I'll be searching through CISA, CISC, and so on. And there are only so many CISP classes, so I can locate it pretty quickly. Within the class, I have different topics. So I know we are in topic 3 right now. Oh, topic 2, sorry. And nested statements. So we are now back to where we are supposed to be. Good. Let me see. I will present the more complex example first, just to show you what we mean by structured programming. Okay, this is not bad at all. Okay, trust me, this is not bad. It just has a loop inside another loop. Okay, if you look at line 5 to line 8, that's one loop. Okay, it has a while, it has a matching and while. And then you look at line 3 and line 10, that's the outer loop, okay, because it is also starting with a while and ending with an and while. So now there are 2 questions. The first question is, what is this logic? Okay, what does the logic look like? Okay, how do we go from one line to the next? That's the first question. The second question is, when we execute this algorithm, what does it look like? Unfortunately, both answers are actually presented in the slide itself. Okay, so the first thing I want to do is to look at structurally, what does it look like? That. Yeah, this took me a little while to draw, but that's kind of the structure of the code. you can see that there's a loop in the inside, because this is a loop, right? You go in, there's a branching point. Once you perform an action, you have to go back to the branching point again. This is one while. There's another construct exactly like that on the outside of this. Okay, so we have a loop inside the loop. Okay. Are there any questions about this picture? No questions about this picture. Okay. So this is structured code. Okay, we have some construct within another construct. So the next question is, do we have any type of inherent limitation of what can be inside what else? There's only one limitation. Assignment statements are the last level. You cannot have something embedded. You cannot have another control statement or control structure within an assignment statement. So you can look at assignment statements as individual files. Then what about a conditional statement? What about a pre-checking loop? What about a post-checking loop? They're more like folders. They're containers. Are we doing okay so far with that analogy? What can a folder contain? It can contain individual files, right? But what else can it contain? Subfolders. You look at each one of those subfolders, what can it contain? Same thing, individual files or other subfolders. Is there an actual physical limit of how many levels of subfolders you can have? Technically, yes, okay, but practically no. Okay, same thing with programming. You can nest one structure within another one. That one in return is nested within another one, and so on. Are we doing okay so far with that logic? Okay, very good. So to illustrate the application of something like that, I can leave this. I can leave it up to you guys to read this part here. But instead of solving this problem, let me solve a real actual problem. Let's think about finding the maximum of 3 variables. So now we have w, x, y as incoming variables. I want to find the maximum of w, x, y and store the maximum into variable z. How do we do that? Well, I think we can borrow something from finding the maximum of 2. Okay? All right, so I would draw this as a picture, okay, so, which means if you want to follow the rationale, the logic of how to come up with an algorithm, you kind of have to write it down. The reason why I use the whiteboard is not because I want you guys to write something on your actual notebook, but because a picture helps in this case. Now I can pre-draw a picture and just show it on the screen, But that's not nearly as good as a presentation tool because I want to show you step by step how we do things. How do you come up with an algorithm? Okay. We come in, we know this is, this is going to be involving some kind of branch because the maximum of 3 variables can be any one of the 3, which implies that you need some kind of branching to determine which one is the actual maximum and then change z based on that particular variable. So it implies branching all over the place. Unfortunately, each branch can only go to 2 alternatives. There's no way to go to 3 alternatives out of 1 branch. Most programming languages do not give you that option. Which also means in this case, the question that you are asking has to lend itself to, okay, which way are we going? This way or that way, okay? We have 3 variables. So I'm just going to randomly try something. That's one thing that you can do easily with a programming class is I want to try this one out, okay? See what happens. I want to try that out and see what happens. In programming or most computer science classes, even in security, because you can back up a virtual machine, then you can actually just try out something, see if it works, or see what is the actual result. And then if it's not what you want, you can do something else. Don't try this with woodworking, welding, or gunsmithing classes. Bad things usually happen when you say, I don't know, teacher hasn't taught it yet, I'm going to try it out. Okay? Yeah, usually people lose a limb or something, or worse. Okay, but in the software class, in the programming class, it's not a bad thing to do. So I have 2 variables. I'm just going to say, okay, let's just compare 2 variables. Okay, write this out a little bit better. Maybe just that. Okay, W is greater than X. That's the question. Okay, but Tag, you said there are 3 variables. Yes, I did. But I have to start somewhere. I'll just start with these 2. Okay. Once again, we have a true branch, we have a false branch. When we follow the true branch, it means that yes, we have just confirmed that W is in fact greater than X. Okay, that tells me something. But it doesn't tell me anything between it. Okay, the one thing that we confirm if we follow this branch is which one cannot be the maximum. X cannot be the maximum. And we're down to how many variables? 2. And do we know how to find out which one of 2 variables is the maximum? Yes, we do. So now we can just say, we know how to do it. We just copy and paste that code and we already know how to do, right? So once again, we branch, and this time the question is, we only have W and Y to talk about this time, right? If this is true, then W is the maximum. Z gets W. Aha! That's great. We just confirmed that in this case, if we ever get to this point here, W has to be the maximum. There's no other way that we can end up here. If we end up here, who has to be the maximum? Y has to be the maximum. Good. Okay, but you also have to remember that after each branch, they have to merge. Okay? Yep.
What if they're equal?
If they are equal, okay, let's think about it. If W and Y are exactly the same, W is greater than Y is still false, right? So we go for the false branch, and we'll use Y to update Z, which is okay because in this case, W and Y are exactly the same. Which one you use to update Z doesn't matter. It is still the right result. Because the maximum of 1 and 1 and 1 is still 1. Yep.
But if W and X are equal,
then we go to the other side, right?
yeah.
Which is okay. There's
Okay.
no problem with that. Okay. So when we get to the other side, we're just going to extend this one out here. So which one do we rule out in this case? W is greater than X is false. Which one am I ruling out? W. Okay? But then you say, but we cannot rule out W because it can be the same as X, and so they can both be the maximum. Yes, but for exactly that reason, we can just forget about W. Because X is the same as W. We only need one of those 2 if they are exactly the same. So that's why we can safely discard W from our consideration on the false branch of the outer conditional statement. Then we are left with which two variables? X and Y. And do we know about how to find the maximum of X and Y? Come on, give me a break, right? I mean, we have talked about this how many times? 10? 3 times today already? I didn't actually count, I just pulled a number, okay? But multiple times. This is something that we have done so many times already. All right, we know how to do that. You know, it's a branch. We ask whether X is greater than Y. If it is, then X is the maximum, use it to update to Z. If not, Y is the maximum, use that to update to Z. Like that, that. And remember, the alternative branches, they have to merge first. Okay, so merge these two. Okay, what do we do with this and that? The exit points of each inner conditional statements. They also have to merge. Okay, fine, they merge. Now we have a pictorial representation of the logic that we want to express. Okay, several things that are important. One is, you know, the actual logic. Okay, that's good. But the process is important as well. When you're given a problem to solve, where do you start? So go ahead. Yeah.
You just start with something.
You-
You 2 out of the 3, right?
Yep, you start with something, and you know that comparison is important because you have to determine the ordering between the 3. So you just say, okay, well, give it a try. Okay, it may not work out. That's okay. Then you just say, okay, this doesn't seem to be working out. Try something else. Okay. All right. So given this is the structure of the code, how do we put it into pseudocode? That's the next thing, right? Once you know the actual intended structure of the code, and this is structured, how is this structured? We have conditional statements inside another conditional statement. Let me use a different color to highlight the inner conditional statements. What looks like a conditional statement to you? The overall thing looks like a conditional statement to you, right? But what else looks like a conditional statement? Does that by itself look like a conditional statement? One incoming thing, branch out, 2 ways to do things, but they merge, and then we exit. Conditional statement. What about this thing here? Looks like a conditional statement to me. One way to come in, split, do different things, alternative paths, merge. Okay? But you can look at this entire thing as one thing to do. Look at each red square as one thing to do. After all, a conditional statement is a statement. It is just one thing to do. Look at the other one as a statement. It's just one thing to do. It's just that it has some details. But then when you look at the overall picture, it is another conditional statement. One way to come in, 2 alternative branches, things to do for each alternative branch, they merge and get out. Okay? That is structure. Okay? Because now we have conditional statements inside a conditional statement. Next, how do we express this? Now that we know how to draw this logic, how do we express it? I'm going to use mouse pad for this, which is kind of the same thing as notepad. But I have to be careful because it crashed last night for some reason. Okay, the way I do this is kind of strange, but it works for me. This is how I do things. Whenever I know I need a conditional statement, I spell out all the components of the conditional statement without specifying the details. And then I go back in and fill in what I need to fill in. The reason why I do this is because this way I don't have to worry later on. What is this end if ending? Which if is it ending? Which if is this else corresponding to? I don't have to worry about those things anymore because they're already here. In other words, if I use a folder as an example, I'm creating the structure of folders first, and then then I put the files into the folders. Okay? Well, to mirror the structure on the whiteboard here, we have another conditional statement here. If, then, else, and if, then, else, and if. I have not specified a single thing that is useful that we are actually going to do, but I have the structure down already. In other words, this is basically the same thing as the picture, but with all the boxes being empty. But I like to do things this way because this way I don't have to worry about, as I specify the detail, oh, what is this else ending? Where do I specify the else? Where do I specify the end if? It's already here. Okay. So you guys can help me fill in the blanks now. Okay, I'll just point to, in fact, I'm not even going to follow the order from top to bottom. I'll just point to one random place here, and you tell me what goes in here. If I want that pseudocode to mirror what we have on the whiteboard as the structure of the code, what goes into the blinky cursor? Yes?
If x is greater than y.
X is greater than y. Very good. Good job. Okay? How do you know that? How do you find that x is greater than y in the picture goes into the blinky cursor?
Because it's the second.
That's the else.
Condition. It's the false conditional statement.
It's the false condition of the outer conditional statement. Right? This is the conditional statement that is in the else branch of the outer conditional statement. That's how you found it. Good job. Okay, this is x is greater than y. What goes in here? Yep, go ahead, back there.
Z becomes Y.
Z gets y, okay? This one here. Why? How did you find that?
Because it's in the else branch of the first statement, the true statement of the main.
You can count turns, right?
Yeah.
Okay? Left turn, right turn, we get to here. But in the code, a left turn means following the then branch. A right turn means following the else branch. Okay?
Say that again, please.
Hmm?
Can you repeat that?
Okay. A then branch is a left turn, okay? And then an else is a right turn. Okay? But this part is important because this is basically testing to see if you understand how to read a picture and be able to turn it into text. Because ultimately in this class, we only do pictures up to a certain point, maybe next week. Then we will do text only, pseudocode only. Okay? All right, so let's work this out completely. Okay, so we'll do z gets y. And you can see that I'm definitely jumping around because I want to jump around. What goes in there? Okay, let's count terms, okay? In the picture, in the pseudocode, this is an else branch, which is a right turn. But after the right turn, we have a then, which is a left turn, right? So in the picture, we follow the right turn, and then the left turn, z gets x. And we'll just jump around here. This is the easy one. It's the first thing that we ask, okay? W is greater than x. W is greater than x. Is it true or false? Okay? W is greater than x. And we'll just jump all the way back down here. Okay, two else's. I can only get here if I take this else, but I can only get here if I take the second else. So we are talking about two right turns. First right turn, second right turn, z gets y. And we get back here. What goes there? Two left turns, right? So after two left turns, we get z gets w. Okay, very good. And we only have one thing left to do, which is the question. It's the question after we take the first left turn. Is w is greater than y. Good job. we go. But this is a useful exercise. If you say, oh, this is a really awfully boring exercise, congratulations, you got it. Okay? That is the point, okay? Because once you get the material, okay, the rest is kind of like mechanical stuff, it's just chore. But if you're not getting how the code of that thing corresponds to the structure, then you need to read the instructions. You need to read the slides a little bit more because you need to understand what type of logic are we representing in the picture and how it is also represented in text, in pseudocode. Different people process information differently, so I cannot really get how you're processing it. Some people can get this right away. Some people may need a little bit longer or a different way of presenting the same material. Okay? Are there any questions about all this stuff? No questions? Okay, this is something new, completely new. I have never really used an activity like this before, where I draw the logic out as a picture, give you the skeleton of the control structure, and then ask you to go, okay, what is that? What is that? Map between the two.
I think that's it.
You think so? Okay. So I will probably give you guys activities like this, okay, as a homework assignment, so that you can just kind of do something like what we just did. All right. So we are running out of time. In fact, 2 minutes out. Yep.
Do we have any other homework except the Libre office assignment?
At this point, we only have that one, but I'm going to use what we did today as a basis of the next homework assignment.
Are you going to post that online?
Yeah, I'm going to post it online, and you will receive an email as a result of that. Okay? Yep. I forgot. Yes.
We're all here.
So we're all good. Yes. It's okay. It only takes 3 absences. Okay, people who keep missing, I will still get them.
It's funny. I've been playing computer games ever since I was a kid, and a lot of computer games